In this example, we are looking to find the slope of the curve, and this is our curve. It has x's and y's in it. So we're going to be finding the slope, which means we're going to be doing the derivative of this at a particular point. So we need to do the derivative, plug in our points, and let's go ahead and figure out what our slope is. So let's go through it. So we're going to be doing the derivative with respect to x of this. Right? So that's a 2x plus y to the 1/3 equals y. Okay, so that's what we're doing the derivative of. So this 2 is really nothing. It's just going to kind of sit in front, and it's going to be multiplied by this piece. So if we're doing the derivative of this, we're going to bring the 1/3 down. So this is a chain rule. So 1/3 times an x plus y. And then we're going to subtract 1 from that, which will make it a negative 2/3. Because it's a chain rule, that's the derivative of the outside, and then times the derivative of the inside. So derivative of x is 1. Derivative of y is 1 times dy dx. All right, so there's the first part. And then that is going to equal then this side, derivative of y is just a 1 dy dx. All right, so that is our derivative. So here's the point where I got to realize, how much do I really need to do? In the past, this past problem, we were asked to find the equation, which meant same thing. We are finding the derivative, which is the slope equation. We plugged in our point and we got our slope. However, this one might be a little bit more complicated. Really doesn't matter. We could have done the same thing here. Is it's not asking for, so write this down. This does not ask for dy dx. So that means in this one, we did extra steps to go ahead and isolate the dy dx and just purely create a slope equation. But this is also our slope equation, just kind of a messier version of it. And if they're not asking for the actual perfect slope equation where we've gotten this by itself, so I would then just at this point, go ahead and plug in 4, then solve for dy dx. Because it's going to be much easier to solve for dy dx because these things are going to just turn into all numbers and it'll be easier to solve for it. I just need the slope. So kind of realize of when you can kind of cheat it and when you can't cheat it. It's not asking for this, so we don't need to do that. We didn't need to do it on the last one. At this step, as soon as we did our derivative, we could have plugged in this coordinate of 3, 2, and then went ahead and solved it, and we would have got it 8/9, and it might have been a simpler approach. So same thing, it's just asking for a slope. So let's plug in our 4. So we have our slope is going to be 2/3. And if I smush that together, that's 2/3 times x and y are the same. They're both 4s. So 4 plus 4 raised to the negative 2/3 power. And then times 1 plus that I don't know, which I will be solving for eventually. And then that equals, I don't know, I'll be solving for eventually. So this is 8. So 2/3 times 8 raised to the negative 2/3 power times 1 plus dy dx equals dy dx. So a little bit of side work on this thing. This 8 to the negative 2/3 power. What it equals is the root is your denominator. Your denominator is your root. So it's the cube root of 8 being raised to the negative 2nd power. So we're still going to square it eventually. We're just going to make it a fraction. So cube root of 8 is 2. And then if we raise that to the negative 2 power, 2 squared is 4, but it just goes into the denominator. So that piece, so we got 2/3 times 1/4 times 1 plus dy dx equals dy dx. All right, so let's see what else we can do. So this is going to multiply out. That's going to simplify to a 1. That's going to simplify to a 2. And then that's going to give us a 1/6. 1 plus dy dx equals dy dx. We're going to want to distribute to get rid of our parentheses so we can move things around. So then that's going to be 1/6 plus 1/6 times dy dx equals dy dx. We're getting there. And then let's pull the dy dx's together. So let's subtract this one over, minus a 1/6 dy dx minus a 1/6 dy dx. And right now this is a 1, so it's like 6/6. So we'll have a 1/6 equals, so 6/6 minus 1/6 is 5/6 dy dx. Whew. And then to get this by itself, we're going to multiply the reciprocal over to the other side. So times 6/5. Sixes go away. That would totally cancel. And our dy dx, our slope at that particular point, is going to be 1/5. And that is our slope. So kind of messy, a little rough. Implicit differentiation is just a little bit harder than your normal. But good news is we didn't have to get the dy dx by itself. It's just easier to throw these numbers in and kind of manipulate it. It got a little messy with some fractions, but it definitely was probably going to be nicer than us taking this and trying to figure out how to isolate the dy dx.